Welcome you all my lecture series of automata theory and compiler design. In today's class, what we have to see means we are going to see about what is the phases of compiler, how our pre-processed source program is converted into the assembly level language program during some using some phases. So first I list it out what are all the phases required for converting our source program into the assembly level language program. So the first phase is the lexical analyzer, and the second one is the syntax analyzer and semantic analyzer, intermediate code generator, optimization, and target code generation. These are all the 6 phases, and the 6 tools are required to convert our source program into the assembly level language program. So among that, what we have required for all the phases are the symbol table and error handler. So the what is a symbol table means it is a data structure used to store our variables, and what are all the constants and what are all the terms identifiers used in our program. That information is stored in the symbol table. That is a data structure used to store all the identifiers and variables information. So these symbol table should could be updated every phases. So in the lexical analyzer phase, this symbol table is initialized and created and initialize all the variables, memory space, and what is the data type. All the information are stored whenever we are initialize the variable and identifier. That information is stored in the symbol table. And next to the every phases we require some updations, means that updation also updated in the symbol table. Next is an error handler. So the error handler function means it handled for every phase the input, every phase, that is call it as a translator. For every phase we require some input and produces some output. If the statement is correct, it produces an output as a correct one. If it is not, means it produces an error. For example, in the lexical analysis phase, suppose as a human being we are doing some spelling mistakes in our typing program, means that spelling mistake, that is adding, removing the characters or misplace the parentheses. These are all the simple mistakes we can make in the lexical analyzer phase. So that mistakes are reported by that analyzer, and also it handles some error handling mechanism done by the error handler for that phase also. So the error handler is a very important for all the phases, because for every phases the statement is not correct, means it produces an error. So that error is handled by some error handling mechanisms or algorithm by the error handler. So this is the phases of a compiler, and 6 phases. Among that we have the symbol table and error handler. Now we will see what is the input and output of the each phases. First, the input of the lexical analyzer means it is a high level language program, that is the source program. It is in terms of any languages like C, C++, and Java. So that input is given into the lexical analyzer, that is a pre-processed source program, because the output of the preprocessor is given into the input to the compiler. Already we saw that in the language processing system. So that input is given into the lexical analyzers. The lexical analyzers read the statement line by line, left to right, and produces the output as a tokens. That is, a token is nothing but it separate all the statement in terms of when it is an identifier, it is a identifier, it is a variable, it is a constant, it is a operator. So all the terms are divided into the tokens. In terms of using some pattern matching algorithm, it produces the token. The next token is given into the syntax analysis phase. That is, the syntax analyzer convert our token into the parse tree or the syntax tree. So the parse tree means the parse tree is generated in terms of using the context free grammar. From the tokens the parse tree is generated. So parse tree is nothing but the leaf nodes are an leaf nodes are the operands and interior nodes are the operators. That is a syntax tree. So parse tree means our start symbol is derived into the input string. So that derivation is given by the parse tree. Next, that parse tree is given input to the semantic analysis. So the syntax analysis check whether the statement is correct as per the programming language construct syntax. If it is correct means it produces the parse tree with the help of the context free grammar. If it is not, it report an error. So the error handler handle that error in the syntax analysis phase. Next phase is the semantic analysis. In semantic analysis phase, the input is the parse tree, the output is some information hold in the given parse tree is produces as an output. So it is called it as an annotated parse tree as an output. Next, the annotated parse tree is given input to the intermediate code generation. That is, that statement is given into the intermediate code generation. So that intermediate code generator generate the given statement as a 3 address statement. Our given source program statement into the 3 address statement. Why we need that intermediate code generator means our source program is directly converted into the assembly level language program, means it is a very tedious task. So first the source is converted into the 3 address statement. That 3 address statement is converted into the assembly level language program, means it is that process is very easy compared with that direct conversion. So the intermediate code generation generate the 3 address statement from our parse tree. Next is a code optimization. So code optimization function is it optimized our in 3 address statement. What is an optimized means? Suppose any statement is repeated, there is a redundant statement is there, or any statement is a cost effective, means that statement is replaced and optimized statements are given as an output for the code optimization phase. Next is the code generation phase. In the code generation phase, it take the input as a code optimized code and produces output as an assembly level code. So what is an assembly level code means? The statement contains the mnemonics. For example, you have a statement like C is equal to A plus B, means there is a 3 variables are uses. That 3 variables are stored in some registers, and we are having the value of A and B already we are initializing, means that A and B also stored in that registers. So using the statement add A comma B, the statements are the value inside A comma B is added, and result is stored in the output left hand side, that is a C variable C, means so move move A comma B, there is a some registers are used, means move R1 comma R2. So the result are stored in the R2. That R2 is result is move into the variable C. So these statement are in terms of mnemonics, that is called it as a assembly level language program. That is an output of the compiler. So these are all the 6 phases are required in terms of the compilation process. Our pre-processed source program is converted into the assembly level language program. I hope you will understand how that each phases are converted and what is the input and output of the each phases. Thank you.